Okay, welcome back. So I realized that in the first video I ended it before I actually returned to this visualization. So I wanted to make a quick video here to kind of go through this in a little bit more depth and then also go to another visualization here. And so this is from the Seeing Theory website. Um, so confidence intervals, again, we're specifying some sort of range of possible values within which the population parameter is likely to fall or likely to occur. And so to go over this visualization, so we can choose a probability distribution to sample from. So again, we can make it uniform. We can do all kinds of stuff here. Exponential. We'll just stick to normal for simplicity's sake. And so we can change sample size and confidence level. Here, alpha. Yeah, we'll define alpha later in this course actually. So there will come a point at which this makes a lot of sense. But for now, just know that um, or I guess to define it in terms you're already familiar with. In the discussion, I think it was the last module about standard normal transformations in the Z table, and there was column C in that table represented the um, area between, or basically the area in the tail of a distribution. That's what alpha basically represents. And so 1 minus alpha, if alpha is 0.05, 1 minus alpha is 0.95, right? So that's a 95% level of confidence, right? So you can basically play with this. If the 1 minus alpha confuses you, just look at this number. So here, 99% confidence. Um, Large sample size, if we start sampling with 99% confidence, right, we're going to see that most of these intervals are going to contain the population mean. In other words, most of these confidence intervals are going to overlap with this axis here, the actual value of the population mean. And so let's go and drop alpha down. Let's see 0.5. And you can see there that our confidence intervals are shrinking, right? They're much smaller. Again, because we have less confidence. In order to be more confident, we have to increase the range. Whereas here, conversely or inversely, by decreasing the confidence, we are also decreasing the range. Right, and so let's go to 95 here. Come on, there we go. So we stick to that. And if we drop sample size, what happens? Their intervals increase? Yeah, that's the answer, right? As sample size increases, right, our estimation essentially increases as well. Um, yeah, and essentially what that, or the reason for that is, as you can see here, the spread of sample means is increasing more broadly, right? So that's the basic principles that we've already learned in this course are holding true. As sample size increases, the more accurate our sample means will be in comparison to the population mean. So you can see here, like this confidence interval is insane, right? The sample is tiny. As we up the sample size, our sample means are getting ever more close to the actual population mean. And as a result, our confidence intervals are decreasing, but not as dramatically as if we were to decrease the estimation, right? So you can keep playing with that, come back to it, and so you can see here these are actual statistics for the amount of intervals that contain mu and exclude mu. And so to briefly go over another visualization, if you I'll refresh this, you can see it starts right off the bat here. This is another one very similar. So here we can see these the population mean is this red dotted line. The sample means are these blue dots, and then these lines are the intervals. And yeah, we can adjust the speed if we want to slow it down. We can speed it up. That's a little bit too fast. There we go. And we can slide this up here to adjust the confidence. And so now you can see, okay, that's 99% confidence interval, 18% confidence intervals, right? So same thing is true as we decrease our confidence, we decrease the range of the intervals. And then as we increase confidence, we increase the range. Here the sample size is 5, so let's up this. Can I type this in? Yeah, I can. So 30, and you can see immediately our intervals dropped, and our sample means became closer to the population mean. Whereas if I go to 2, then what's going to happen? Our sample means are going to go more broad, and the intervals are going to go broad as well. Right, and so the reason I love these things is because they really help to visualize all these principles we talk about, rules of thumb and trends and all this. That when we're reading it or hearing it, to me, it's just like, okay, you're just retorting facts. But actually seeing it, I think, really helps the principles click for me. So I hope that this helps you as well. Yeah, and so I encourage you to play around with these, spend some time with it. I'll make sure to link these websites in the content for this week, and we'll see you in the next video.